Good afternoon, children. Welcome to 6th standard online physical science class. This is standard 6 physics class, unit 7, magnetism. Today we will start this lesson and discuss about this magnetism. So what is magnet? You may have noticed that when you shake a pin holder, many of the pin sticks to the opening as shown in the figure, right? This is because a magnetic ring holds them there. Pin holders and the colorful stickers used to attach slips of paper to the door of a refrigerator are common examples of the use of magnets in our daily life. Magnetic stickers usually have a small button-shaped magnet at the back, isn't it? Like that, as it is shown in the figure. So, as early as 800 BC, the ancient Greeks probably knew that magnetite, an iron ore mined in the province of Magnesia, attracted iron. The philosopher-scientist Thales of Miletus, who lived nearby, may have been the first Greek to study magnetism. So, the Greek people were the first to study this magnetism. The term magnet was derived either from magnesia or from manganese, the name of shepherd who supposedly discovered magnetism when the iron top of his stick and the nails of his shoe stuck to some rocks containing magnetite. So, these magnets were first discovered by the Greek people. Magnetic and non-magnetic substances. Magnetic and non-magnetic substances. What are magnetic and non-magnetic substances? Substances that are strongly attracted by magnet are called magnetic substances. Okay, which are all attracted by the magnet are called magnetic substances. For example, iron, cobalt, nickel and their alloys, that is the mixture, their mixtures are magnetic substances. Some compounds of iron, cobalt and nickel are also attracted by magnets. Okay, so some compounds of iron, cobalt and nickel and also their alloys are attracted by magnets and they are called magnetic substances. What are non-magnetic substances? Substances that are not attracted by a magnet are called non-magnetic substances. Some examples are wood, paper, water, copper, glass, gold, silver, rubber, plastic, stainless steel and leather. So all these things does not attract by magnets. So they are all non-magnetic substances. Do you understand, children? Yes. Many people believe that all magnets are made up of iron and that magnets attract all objects made up of iron. Neither of these beliefs is fully correct. Many magnets do not contain any iron at all. They are made up of alloys of cobalt, nickel and other elements. One such alloy of aluminium, nickel and cobalt is called alnico, A-L-N-I-C-O, alnico. Other magnetic materials called ferrites also do not contain iron. On the other hand, stainless steel, you know all our kitchen utensils are mostly made up of stainless steel. Am I right? Which contains a large proportion of iron, is not a magnetic material. Okay, stainless steel is not a magnetic material, though it is made up of huge amount of iron, but it is a non-magnetic material. Is it clear? Magnets and their properties. An object which attracts other objects made of magnetic material is called magnet. The properties of magnets and the manner in which they interact with each other and with other objects made of magnetic materials is collectively called magnetism. As we shall learn later, magnetism also includes those effects of electric currents that are similar to and closely linked with the properties of magnets. Magnets are available in different shapes, size and stints at stores for scientific supplies, hobby shops and some toy shops. The common shapes are shown in figure. So this is a bar magnet. The first one is a bar magnet. This one is a horseshoe magnet. It resembles like a horseshoe, no? Yes. And this is a disc magnet, ring magnet. So there are various shapes are available. Is it clear, children? The poles of a magnet. Let us do some activity. Spread some iron fillings on a sheet of paper or board. Place a bar magnet on the sheet and move it around. Alternately, sprinkle iron fillings over a bar magnet. Pick up the magnet and tap it gently a few times. You will note that iron fillings stick mostly to the ends of the magnet. Okay, so this is the diagrammatic representation of the activity. This activity shows that magnet's property of attracting iron is the greatest at its two ends and almost nil elsewhere. It is in fact possible to identify 2 points near the ends of a magnet where all its magnetic properties appear to be concentrated. These 2 points are called the poles of a magnet. They lie slightly inside the 2 ends. The distance between them is approximately 0.85 times to the length of the magnet. So, they are slightly inside the 2 ends. Okay, slightly inside the 2 ends of the magnet. Okay, what is the length? Approximate length is 0.85 times the length of the magnet. From the magnet, 0.5 times, 85 times of the length of the magnet, the poles will be present. Is it clear, children? You may have wondered at the unusual shape of horseshoe magnet. The advantage of the shape is that the 2 poles lies next to each other. Isn't it? The 2 poles lies next to each other in this case. Hence, their combined attractive power can act on the same object. So, in the case of bar magnet, they are at opposite directions. The poles are at opposite direction. But think about this horseshoe magnet. Both the poles are lies nearer to each other. Hence, a combined attractive force can act on the same object. So, this is the advantage of horseshoe magnet over the normal regular bar magnet. Is it clear? Hope you have understood today's class very well, children. Let us meet in the next class. Meanwhile, complete your assignment and report in the group without fail, children. Also, prepare well for your upcoming exams. Thank you. Meet you again.